Hello everyone, my name is Franco Pucci and I am the technical consultant for the STS Association. I've been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. In this video, we will deal with the simulators and tools available to members of the STS Association, and the virtual meter is the subject of this video. We have dealt with the STS simulator already and the virtual security module. What does a virtual meter do? Well, essentially it emulates a fully functional meter of any type. Let's have a look. So all meter types, that's including electricity, water, gas and time, plus all the currency meters. It does conform to the STS edition 2 specification, and it has been certified according to the latest certification documents. What I mean by that is I've run it through all of the tests as would a normal meter. All major parameters may be set by the user, and we'll see that in the demo. It supports the Virtual Token Carrier 07 and Virtual Token Carrier 08. That's the DLMS COSM. Supports EA07 and EA11 algorithms. That's the STA and the MISTI one. And there are two versions available, the standard version and the DLMS version, although the DLMS version is still in beta test. What can it not do? It cannot be used in place of a real meter, obviously. So let's have a look. Okay, so this is what the panel of the virtual meter looks like. You can see it has two panels, the meter panel and a meter settings. We'll get to the meter settings in a minute. The meter we're currently looking at is an electricity meter, kilowatt hours, token carrier type 02. The latch is open because there's no credit in the meter, and this little icon shows that it's an electricity meter. You have a keypad where you can enter tokens, or you have a little edit box here where you can enter a token. If you put a token in there, then you press this button below it and it sends a token to the meter. Okay, we can also read registers, and I'll show you what that does in a minute. But first of all, let's just have a look at the keypad. I'm going to put in some arbitrary token. Okay, we entered a obviously incorrect token and it came back with a CRC error, which it's supposed to do. You can partially enter a token and then backspace if you so wish. Okay, you can also connect a load to this, and then it will also show you in the meter, or you can set the tamper as if the meter has been tampered and it will react accordingly. Okay, let's go into the meter settings box, and you can see here that under the meter type you can select any of electricity, water, gas, time, or any of the currencies. You can select whether it's a single phase or three-phase meter. You can select whether it has tamper detection or not, whether it has phase imbalance or not for a three-phase meter. Number of key change tokens supported, in this case it's 2. Token carrier type, in this case is token carrier 02. Do you have a lockout for this meter? You can enable that if you wish. Then if you put in incorrect tokens, after each incorrect token the lockout time gets longer and longer. Is key expiry number supported, and you can initialize the TID stack back to all zeros. Okay, the DRN number, there it is. In fact, sorry, when you initialize the TID stack, it initializes it to the value given in the conformance test documents, which is shown there, 5A45A1. Then you have maximum credit that's allowed in the meter, the lockout time remaining if you want to have a look at it. The current key change timeout is 60 seconds. The current meter credit is 0. The meter load, if you apply a load, then phase 1 will have 1000 watts on, and for the moment phases 2 and 3 will have nothing on because it's a single phase meter. It has a key revision of 1, a tariff index of 1. The firmware version is 0102, and the lockout time increment after each incorrect token is 5 seconds. Then it'll ask if you want to disconnect the load and tamper. Down the bottom you've got algorithms. First of all, it tells you what key you're in at the moment, and this one is in a DUTK and it's using EA07. and there's the meter key. And then you've got a key expiry number at the moment, which is set to FF in hex. And then in here, you can select any of the CTS test entity types for doing the CTS test. Let's just go back to there, and I'll put in a meter key of ABs. Okay. On the right hand side, you can see supported registers for this meter. Any of the grade ones are ones you have to support if you go through Virtual Token Carrier port 07, and the blue ones are ones you can elect to support. So if you support a ticket, now it doesn't mean that if a register is supported that it's also enabled. If you want to support it and enable it, then you also tick the appropriate enabled registers checkboxes. Okay. And then what it supports as far as a test display tokens, you can select it here. And then for the read control, you can say whether when you read it, it only shows you supported registers or supported and enabled registers, or all of them. So let's go back here and read the registers. The registers in this meter show you many things, shows you the software version, lockout time remaining, the decoder reference number is all zeros, encryption algorithm 07, tariff index 01, etc, etc, and you can essentially read all of these as you set them. You can come and have a look. Number of key change tokens supported are 2. Okay, so let's do something. Let's generate a token for this meter. Now remember, this meter's key is AB. So let's open the simulator. And in the simulator, there's already a key ABAB, which is wonderful. Let's generate a class 0 credit token, and let's put in, 50 kilowatt hours. There's the token. I'm going to grab that token and I'm going to insert it in here and say enter token. There's our 50 kilowatt hours. The meter now has 50 kilowatt hours inside it. Okay, if we do a clear credit, say, so let's go back to the simulator, and we want to encrypt a meter specific management token, and it's a clear credit, and let's create the token and let's put it into the meter over there. Clear electricity credit, and there you go, it's cleared, and the latch is once again open. So let's put another credit token in, just so that we have some credit in this meter. So we'll encrypt the class 0, generate a electricity credit token. There it is. Let's grab it. It's 50 kilowatt hours again. Put it into here. Okay, there's our 50 kilowatt hours, and you'll notice now that the latch is closed. We can connect the load here. There's 1000 watts. When you connect the load, you'll see that after a short while, the meter load comes up 1000 watts, and this little LED will flick every now and then, and as you can see, the kilowatt hours is actually going down. Now this is not metrologically correct, but nevertheless it shows you that the function is working. We can go into tamper, and the tamper sign comes up, and the load is automatically disconnected because in the meter settings we selected disconnect load and tamper. Okay, now I'll try and put in a water token. Let's go back to the simulator and let's create a water credit token for this meter and enter it, and you come back with a token error. Obviously it cannot accept that token. It did not increment the load, the credit, and as you can see, then it is functioning correctly. So let's maybe do a key change as the last thing. The meter is currently on ABAB, so I'm going to go back to the simulator, and I'm going to go to a meter specific management. We'll go to a key change, and we are going to go from 1 2 3 4 5 6 to 1 2 3 4 5 7. Key expiry number is fine, key revision is fine, that's fine. And what I'm going to do is I'm just going to say force the keys and I'll put the new key as BA, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's create these two tokens, and I'm going to insert the first one, and it shows you KCT1, which is correct. Then I'll insert the second one, and it should come up with accept. Right, key change done. There we go. Key change has been done. Has not affected the credit, and now the meter key is BA instead of AB. Okay, and we can do the same thing, and you can play around and simulate. For example, you can now go to EA11 and do an EA11 token, which will then give you 4 key change tokens. Essentially, it's a full-blown meter, and you can play around with it. So I really hope you have fun with this. And please, if there's any changes that you think are worthwhile, even in this simulator, let us know, and we'll try our best to accommodate you. Okay, then the second version of this virtual meter is the DLMS COSIM or VTC08. Now, this is pretty much exactly the same thing, with one exception. You've got OBIS codes now that are supported. So according to the DLMS, you can put your short name, logical name, class ID, attribute number, access, whether it's read or write, and you can query these or write to them as specified in the DLMS Blue Book. And for that, we will be publishing this version a little later because it's still in beta test. But the STS 101-2 specification essentially tells you how to interface. But the rest of the meter looks pretty much the same and will function pretty much the same. Okay, again, if there's any questions on this or you would like to see anything different, please let us know. This brings us to the end of this video. I hope you've enjoyed it and hope to see you soon. Goodbye.